Can we see your, are you going to share your screen at all?
Yes, let me
Let's see
share
that.
my screen. And does that work?
Yep.
Okay, cool. And then, let's see. All right. Oh, okay. Do the Zoom things pop up in the shared screen?
No.
No? Okay.
No.
So like
So
if I have the like attendees and other things listed, it's not gonna.
no.
Okay, cool.
So if you bring up chat, like so you can read questions as I'm reading them off to you.
Yeah, so that's the Q&A?
Yeah, that's the Q&A.
Okay, cool.
It's not going to distract from your presentation.
All right, great. That's workable. And there's a fair bit of people here, so maybe I'll try to do an interactive one.
Okay, yeah, completely, totally not a problem. I'm going to go ahead and mute and turn off my screen, but I'll come back on for some visual representation as soon as you start anything that's Q&A related.
Okay, sure. So are we ready to go, or are we waiting for anything?
Yeah, let me just make a couple of quick announcements, and then I'll like start the video and do the official thing.
Okay, cool.
For all of those of you who are joining us, thank you for being with us today. We're going to try something a little bit different because, well, first of all, Aaron, unfortunately, is unable to share his face with us. So we'll be seeing just his screen today. He'll be the great voice in the void. That said, he's definitely here, obviously. He's going to try to do something a little bit more interactive since it's going to be a smaller group with us today. And we want to make sure that everybody's following along. And if you have an interest, he wants to address anything that any questions or probably even some fun rabbit trails that you might have.
Definitely.
Definitely. So if you guys have questions, like fire them at us at any point during the presentation, and Aaron will stop periodically for you.
So yeah, I can either stop periodically or I'll be rapid fire through the whole thing, and then we can save enough space to have a discussion.
Yeah, that's whatever's good for everyone. And then and then I'll read off questions that you guys have, just to get more than one voice in there, and then we'll go from there. So let's see. Goodness. Welcome and happy LambdaConf Tuesday, everyone. Thank you for joining us for Aaron Sue's presentation on modern APL in real life. And so thank you, everybody, for joining us, and I'm going to let Aaron go ahead and start.
All right, thank you. And so yeah, my apologies for not having my webcam up. It died, the computer died. So we're working a little bit on reduced resources here. Additionally, since we've got a pretty decent crowd here that I think can contribute a lot to the conversation, I've got so much material here that I don't want to try to cover it all. It'll be too long. So what I'd rather do is I'm going to skim sort of over the top very quickly on a couple of different ideas across the board. And I want you to take note, and I will go back and we can revisit and go into depth in any of the topics that you guys find more interesting versus things that you're just thinking, we know that already. Let's move on to something else. So I want to give you guys an opportunity to sort of drive where we want to get this discussion going. So I'm going to just do as quick an overview as I can, as quickly as possible, and then we'll get into the rest of the stuff. So I've given a lot of talks on APL in the past, specifically on modern APL and how it's different than other programming environments. So why do I want to give another talk on APL and modern APL in particular? And this really comes down to all of my previous talks have been pretty high level, and I've spent a lot of time either on the ground floor of how to do APL or in the theory of how to apply APL in sort of an ideal environment. But there's this coding gap that we encounter in all cases where you've got this beautiful code that makes you want to write APL on one hand, and then you've got this novice code. And I've addressed sort of the novice coding side and the beautiful coding side. But what about this other one, this big hairy one, which is that most APL code that exists in the world is heavyweight production legacy code that has oftentimes spanned decades of product development over many, many different ideas of how product development should be done, many different development environments, many different ways on how you should train people, how you should think about it, all this stuff, and it mixes everything together. And it's very difficult to imagine, well, what should we do today? What can we recommend for people today as a getting started point into actually using APL in the real world? Because there aren't a lot of exemplars right now for that. And the reality is that there are, you know, when we're trying to move towards this, there's just so many styles and approaches to doing APL style programming. And the reality is that there aren't any current fixed in stone best practices guidelines right now. And so I'm trying to address that a little bit here and apply some discipline or provide some guideposts for discipline, because there's so much, you know, liberality in what you can do with some of the APL code that you really need some discipline to target what you're going for and avoid being lost, especially as somebody who's just getting into, say, applying APL to a current real life project. And these are based on some of my experiences applying APL in various either open source domains or commercial domains or product developments or research domains, things that I've seen when I see people try to use APL in anger. And very often there's just too many options and not enough role models. So I'm going to try to provide a little bit of an anchoring with regards to that. And one of the metaphors I like to use here are the three religious structures. So APL has oftentimes in the modern world basically been a desert enlightenment space, right? Where some loner goes out and discovers enlightenment and does a lot of cool things, comes back, has all these neat superpowers, but it seems impossible to replicate that at scale. And in fact, you don't really replicate it at that. You don't replicate that at scale. Oftentimes, if you want to scale it down a little bit more, you've got these monasteries where people of a common culture and goal go to spend time in these places, and you get this structure and you get the shared, you know, commonality and the social dynamic that helps you to learn and grow in that space. But for the most people, the reality is that if you're going to be engaged with some kind of religion, and you guys all know that I like to use the religion metaphor for programming languages. I think that is the current state of the art as it works. And you engage with that in these churches that sit publicly in these spaces. And these are places that are accessible. They're not necessarily doing the biggest innovative research, but what they're doing is they're taking lessons that have been learned from people who have spent more time on the ideas, and they're propagating them out into the world. They're providing education, they're providing these places. And unfortunately, there just aren't a lot of on-the-ground APL churches, if you will, to do this stuff. So how can we try to begin to address that a little bit? Because we know that APL involves some change, but you can't just change everything. If you change everything in your life, that's a recipe for massive chaos. So there's got to be something that sort of sticks around. And this talk is really about what things can we sort of anchor ourselves in, and sort of what can stay the same if we're going to pursue APL in the real world, you know, not just as a toy or not just in this desert enlightenment space, but let's say we want to apply APL to a real world project. Where are the things that we can expect the change to occur, and where are some things that we can sort of lean into that we already know about that can help us? And keep in mind, these are just my recommendations. These are the things, I have a particular approach to this, but the APL community, despite how small it is very diverse in terms of how they approach these problems. And I've seen different implementation approaches to applying APL in the real world, all of which derived enough value to justify the use of APL in that area, but with very different cost-benefit analyses. So I'm going to look at this from the perspective of tooling, architecture, people, and methods. And I divide these up sort of along two axes. There's the concrete stuff, which is the tooling, the people, the abstract, which is architecture and methods, and then the technical and the social aspects. And if I had to pick one and only one thing to concentrate on, it's got to be the social and concrete, the people stuff. That's where I would begin. And this is really the point where I think is the most institutionalized incompetency amongst the programming community is in this space, because we're really talking about psychology here. And the psychology is a thing that sort of is an implicit shared thing that everybody sort of self-selects in the programming community, and we don't really think about it at an explicit level well enough. And when you encounter something like APL, which is designed around a different expectation, different psychological approach, you're going to run into some friction. And that's what you really need to be prepared for and address. And this goes back to the HCI component of things. And that's that, you know, expectation is everything. And if you have the wrong expectations going into these things, it can really mess you up. So I put the way in which you use APL in real life on this spectrum of how much you leverage APL. And what I mean by that is how much you are choosing to use the unique features of APL within your space to achieve an advantage, or to remove the need to use certain other less efficient methodologies or approaches or techniques to mitigate complexity or other forms of that. And I've got this rough sketch here that you can, we're going to look at. And this is talking about expected scaffolding, because when you deal with programming, everybody in the programming community has a certain sort of expectation of the type of scaffolding or anchor points that they rely on when they engage with programming problems. And when you deal with APL, when you look at the more you leverage APL, you'll find that the anchor points that you're familiar with really decrease very rapidly. And this is a huge problem that I've seen over and over and over again with people who try to apply APL in a practical setting, is you very quickly can get lost because you don't expect you're not prepared for the drop in the anchor points, and you haven't put yourself in the right place to mitigate that drop, and you haven't prepared your development processes or your techniques or your training or your onboarding or your design or your methodology or your architecture to recognize that you're going to have this drop in anchor points, and you need to adapt to a different set of anchor points. And this goes back to boilerplate, because APL at the sort of beautiful code level is all about removing boilerplate and removing the unnecessary elements and simplifying your code and your expressions and being able to see the macro level of your code. Now, that sounds great, but the thing is that even though it sounds great, people often forget just how high of a cost removing your boilerplate really is. And it's because boilerplate allows you to psychologically feel like you're doing something without having to spend lots and lots of resources doing hard problem solving, because hard problem solving is expensive. So you spend a lot of time doing your implementation. And so you need to shift your expectations when you're engaging with a programming language where your goal is largely to approach problem solving complexity differently. So, and this goes to the designing versus coding issue, right? Because if you look at how most people do a lot of their programming, there tends to be, at best, a fairly even distribution between designing and coding. So you spend some time thinking about design, and then you spend usually more time implementing that design. You think about the architecture, and then you go implement it. Now, the more you get rid of your boilerplate, the less coding you end up doing. But what is the trade-off there? The more design you end up having to do. And the more design that you do, the more hard, the design is the hard part. That's the big question thinking, the existential questions. That's the part where you really have to, you know, bring your A game. And if you're spending that time doing the designing, you may have cut back on your coding costs, but you're really going to suffer if you expected the experience of doing a lot of coding, and now you're having to do all this design, and your brain is exploding because you haven't prepared yourself and your environment to support a design-heavy coding process. And so you need to be prepared for that, and you need, and this sounds very high level, but this is at the heart of a ton of the friction points that I've noticed in various people in various places trying to implement APL systems, is that they don't have any of the affordances that they're expecting to see. And so they're not used to thinking almost predominantly about design and the coding not taking up a significant portion of their practice. They're used to thinking about the coding more rather than thinking about the design. And that's a very different picture. And so we've taken away the affordances that you're used to, at least in certain designs. Now keep in mind that the less you leverage APL as a language to get rid of those, the more of the traditional familiar affordances you're going to get, but the less you'll be leveraging APL as a language. So for those who aren't familiar with affordances, affordances are just those things that sort of provide the anchor points or suggestions of how to use the thing, right? And so in APL, you have to recognize that you have these implicit affordance expectations when you're engaging with traditional programming code, whether that's C code or C++ or Haskell or Java. Each of those has a set of affordances that you're used to using and working with. And APL gets rid of almost all of those if you want to leverage APL in its maximum form. So the closer you get to leveraging APL in its maximum form, the more you're going to have to shift where you look for your affordances and how you interpret affordances in your programming source code. And that's really important. So type thinking is one of the aspects of here. You've got to be ready to shift the way you think about your types, because in a typed programming language, you're doing a lot of explicit stuff with your types. In an untyped language, very often your types are very simple, and you use the structure of the control flow of the code to do the reasoning about your types. In APL, all that type reasoning is just as important and critical, but now you're doing it implicitly. And so that's something that you have to learn how to think about. Additionally, a lot of the reasons that we're able to eliminate our boilerplate is because we're leveraging mathematical domains in a more explicit fashion. And so our encodings tend to be a little bit crisper, but they also tend to be a little bit more dense. And if you don't understand the ramifications of various mathematical domains that APLers use, then you're going to be at a disadvantage in applying it, and you won't get the same benefits. And so you have to be really cognizant of that when you apply your stuff. And the way I generally recommend to look at this from a psychological standpoint is think about writing literature, not tax code, right? Tax code is what most people are trained to write. High explicit reference points with lots of nonlinearity. Makes it easy to reference, but you can't read the thing, and it's very difficult to reason about emergent behavior. And when you write literature, there's a lot less implicit or explicit structure in the system, and it's designed for a linear progress through the code, and you can see a lot of things that they connect, but it's implicit, right? So very often literature can be very complex under the hood, but has a much more simple explicit structure. Whereas tax code may be relatively simple at some level, but then can end up getting really complex in other dimensions because the explicitness of the language causes so much obfuscation of the big picture ideas. And to get an idea of how these affordances affect us, we can look at the metaphor of C.S. Lewis versus the Internal Revenue Service in the US. I don't know how many non-US citizens we have here. So in this case, Lewis is famous for writing, among other things, a set of children's books that are deeply accessible and enjoyable and usable to a wide range of audiences, of wide age ranges and experiences. And those books are simple, they're direct, they're short, and they're not particularly complex on the surface. But what happens is underneath that, the affordance of the language shows you how to apply an idea to all sorts of different levels of experiences in all different sorts of situations. And that's very much the APL model at maximum effect, right? You've got a very simple structure, but the structure is such that you see, there's all these emergent behaviors that you begin to see and apply, and that move you in different ways, versus the IRS, which has you can read through and pick out and get to any point in the IRS tax code very easily. But understanding the ramifications of how that affects everything else is very difficult. And in fact, making a single change to the IRS tax code is very easy. But understanding the ramifications of that change takes massive amounts of expertise, and you have lots and lots of attorneys and other things to deal with that because the complexity is so great. Whereas the average person can read up Lewis and find lots of accessibility there, provided that they can speak the language. Now, some people do not have a sophisticated enough grasp of the English language, despite the simplicity of Lewis's terms, to appreciate the deeper ramifications there, because there's not enough shared language. So a kid can still appreciate Lewis, but won't see all the ramifications. So a big component of this that I think people overlook is linear versus nonlinear programming. And what I mean by this is, are you writing your code and approaching your program as something that you want to scan through linearly, or are you writing your code assuming you're going to hop around all over the place in the code? And a lot of people I've seen assume they're just going to hop around the code all over the place. And so they don't try to think about the structure of the code for a narrative form or a linear scan through that code. And another aspect of this is emergent versus referent thinking in terms of how you approach the design of your programming systems and how you philosophically approach writing good code. A lot of people just implicitly design code for reference, not for emergent analysis. And you want to, if you're leveraging APL really well, what you're going to be doing is maximizing your emergent thinking and potentially accepting some inefficiencies in the referent thinking. And that's important because my claim would be that the emergent thinking is the most important one and the one we want to optimize for, even if it causes some inefficiencies in the reference side of things. And of course, you can't do this perfectly. You have to be intentional and incremental. And when you do this, nobody is going to write perfect APL code. Nobody is going to write perfect architecture. It can't be done in any language. But this gives you an idea of how to approach the problems psychologically, which I think can smooth the rails a lot, particularly if you give yourself time and patience, because a lot of people want to get into things and they don't give themselves the time and the patience to build up the foundations that they need. So the way you do that is you need to do targeted learning in your approach. And targeted learning means that you focus on learning the right things rather than just trying to skip over certain stuff, and you really get value over that learning, make it really intentional. So one, learn your primitives, learn your domains. I can't iterate that enough. You have to really get a good grasp on those if you're really going to maximize things. Learn your Booleans and learn your number systems. Learn how these work, because I think people underestimate their skill in these systems, and they underestimate how useful they are when doing APL programming. And when you can get really good at these two things, it changes the way you can approach APL code in a real way. Obviously, you have to be able to learn how to encode your information as arrays. That's not as easy as it sounds for some people because they haven't done it a lot. You have to get practice at that. Just learn the stinking primitives. I can't tell you how many times people have this attitude of not needing to learn the primitives because they think they've got the basic idea. That will not work. It's like trying to speak English when you kind of know what the words mean. And part of this is you need to increase your working set of idioms. Unlike in other languages, which have a few sets of design patterns, there are lots of idioms in APL, and you want to really expand the amount of these idioms that you're familiar with. Doing that will have a huge impact on your ability to quickly use APL in a real environment. And this is what really begins to distinguish the hobbyist from the active worker, is somebody who can see these idioms and apply them effectively. And the way you do this is you need to read a lot of different programs. You need to play with a lot of different programs. You need to write a lot of programs. And people just, for some reason, don't want to do that, I find a lot. And one of the big insights here is control flow as data. And I've spoken about this in the past, but this insight is similar to code as data. And if you don't spend enough time thinking about this and understanding this, it can really hamper your ability to interpret and understand APL code. So you need to spend time really understanding what this means. And a lot of ways you can do that is by reading the idiom libraries and reading the classics, such as what's available in the ACM Quote Quad libraries or the Vector Journal. Just to take an example, we might have this spec that can come up, which is you want all the blue disks from a set, but if there are no blue disks in the set, you just want the whole set, right? So this is different than, say, filtering out only just the blue disks or something like that. And very often people will just tack on some branching when they do this. But if you do this in APL, you can leverage Booleans and you can leverage scalar primitives. So you've got your predicate P, which determines like blue or whatever else. And that gives you your mask, which you then ask to determine whether there's any in there, and then you OR over that. And this gives you a selection vector, which encodes the sum or everything mask idiom. And this is a simple idiom to see after you've seen it written. But if you're not thinking with your Booleans, you're not thinking with your sets or your mask idioms, and you're not thinking in the right way, you'll miss this, and you'll end up drastically, potentially increasing the complexity of your code because you missed or you didn't see the opportunities for the simplification because you didn't have enough experience with those idioms. So let's move on to the technical and the concrete, which is our tooling. And here, the biggest issue I see here is just people are not aware of what is available in the APL ecosystem, so they don't understand how to fit APL into a broader system. And so here I just want to give an overview of sort of what is available built into the Dyalog APL ecosystem, so that you can use that when you're thinking about how and where to put in your systems and how to design your systems. Because I think just being aware that this stuff exists changes the game a little bit. So to begin with, we've got namespaces, which is sort of like your module systems in other languages. You've got JSON, CSV, XML, import, export, push button, easy to do. You've got a full-blown object system, which you should not be using internally to develop or architect your system, which you should be using as a way of communicating to to other parts of your system that are object-oriented. You've got a really good debugger in the Dyalog APL environment, so leverage that. You've got a remote IDE, which allows you to either do the debugging IDE experience on Mac and Linux, or to remotely connect to any server that's running APL and is set up for this to do live debugging on your servers remotely. You've got diagramming and charting and plotting wizards and all of these other things that are built in, so you don't need to go to another tool to manage all that, and there's a really nice wizard that you can leverage for this. For some production environments and some enterprise environments, Office integration is a big thing that APL does really, really well, that other languages are not, just don't do sometimes. That can be a point that if you didn't know it exists, you'd miss the opportunities for application. And it can provide a lot of useful domain expert integration when you can work with Excel and Word in a really nice way. You've got the typical RDBMS SQAPL integrations, but very often you don't need an RDBMS if you design your APL right. You've got Jarvis, SockPuppet, and MyServer, which are all different microservices architectures. So MyServer is your typical web server. SockPuppet helps with doing WebSocket channel push notifications. You've got Jarvis, which is essentially a plug and play way of doing JSON and REST APIs for web services. You've got Python, R, and .NET bridges, which allow you to access pretty much all of .NET Core and R and Python in both directions for communicating between the various systems, and these are very nice to use. You've got foreign function interfaces and direct workspace access to do C and C++ integration, so you can call into C and you can call from C into APL and avoid the overheads of doing data encoding and transfers back and forth, so you can get a high-performance C interface into the APL system and back and forth. You've got this big library from dfunds showing you how to write a whole bunch of different ideas in dfunds, which shows you how to do sort of lexically scoped scheme-style programming in APL. You've got the codefunds and isolate systems for distributed and GPU computation. You've got the Conga networking library for doing pretty much a full-stack networking stuff as well as cryptography. You've got a component file server, which is like a native APL array-based networked file server with all the features that go with that. You've got time and date systems that are easy, so you don't have to roll your own on those. You've got PCR regular expressions, built-in serialization and compression, Win32, XAML, and Windows GUIs, web services. If you're in an enterprise environment that's still using SOAP or WSDL, you've got those. You've got built-in support for generating PDFs for reports from Sharpleaf. So for doing data analytics or other kinds of things, APL is great for doing report generation. A lot of things that you might have to find another way of displaying, you can do it through the Sharpleaf system. Performance profiling is built in, easy to access in both directions, so you can see how you're churning and burning up the APL runtime as well as where your code is performing. Math libraries, example vector database to show you how to do column store databases for higher performance in APL systems over your traditional databases. You've got a bunch of code libraries and examples that ship with Dyalog that you can explore to see how you do various systems programming type things. Exception handling, triggers, versioning, just a whole bunch of interfaces for doing introspection on the system. And you have Link, which allows you to map your source code directly to a live running version of the code. So changes in the source code are visible and replicated in the running version immediately, and changes you make in the fly on the workspace to the running code get stored into the source code, so you can keep those in sync very easily. You've got native memory mapped and component or native APL files that you can support, green threading, lexical and dynamic scope. You've got, if you want to write Python in APL, you can do that with the structured statement. So if you want to write this code in your typical fashion, that's also fine. And so some people will write code like that. So we have structured statements to support that kind of programming, rich error messages and error handling and exception passing that you can send through. You've got all these algorithms that are built into the runtime and system that you can leverage and get access to without having to call out into libraries, statistical suites, SIMD parallelism built into the runtime, so it'll automatically launch parallel threads or SIMD instructions where it thinks it can gain a benefit. We've got Haven is a new product that's going to be coming out, and Apple Cart is already out, which allows you to do this live search of a bunch of idiomatic expressions and different ways to do things, sort of like a database of one-liners of APL. We've got the Dyalog GitHub, which will show you a whole bunch of how the tools group does code. And a lot of our products are open source. So you can see how different people do different APL architectures from inside those tools. You can see the Apple Tree Suite, which is an external library of APL code. We've got Jupyter Notebook support unit testing, cryptography through Mystica, big number libraries, and a large suite of idiom libraries. And I can't stress enough how much you should spend time studying those idiom libraries. So among all of those things, the biggest thing I think people should learn first is maximize your use of the debugger. Because the debugger can help you to write cleaner code by not needing to insert all of this extra logging stuff into your code to learn how it works, because the debugger will take care of that for you, and you can explore live in the debugger in a way that's just like working in the REPL, and it's very powerful. Learn to use it. Okay, and a lot of these are a lot of options, but it's best to not use these options inside of your code. What you want to do is use these options at the edge of your code. So you use your tooling for your analysis, or use your tooling at the boundaries of your APL program rather than at the middle. And I am always going to claim that mixing and nesting are not your friends in APL. So avoid it when you can, particularly in your architecture. So here's some things that you think are probably missing, but they're probably not. So for instance, data persistent is just built into APL. You just get it for free. No need. ML libraries. We ran a pilot program with a client recently to explore the ergonomics of ML in APL, and the result is you don't need any libraries. You can do better ML in APL just with the existing APL primitives. No need for any extra libraries or other stuff. You will need to talk to us to use codefunds for getting that code executed efficiently on the GPU. But other than that, I mean, APL is a perfectly fine ML library. Data analytics, the same thing. APL is already its own sophisticated data analytics system. No need for extra libraries on that. Key value and other NoSQL systems. This is the same thing. APL already embeds all the things that you need, not just to build a key value store and NoSQL system, but to be an in-memory key value NoSQL system. No need for extra stuff. It's already one of these. And in addition, you already have access to most of the libraries that you're going to use from traditional computation pieces. So you don't actually need libraries for these, because you can get access to them through various forms of using the arrays in the right position. So you really don't need these libraries as much as people think, because the array primitives already take care of that, and the runtime already takes care of some of the cases that you would think are suboptimal. So let's talk about architecture now. I'm going to get a little more abstract. And again, architecture falls on a spectrum. You can do really heavyweight stuff and you can do really lightweight stuff. I'm always going to advocate for a minimal architecture, because I think architecture is a form of abstraction that generally doesn't contribute useful things to most people in most cases that I've seen architecture used. But if you get rid of a bunch of architecture that people expect to be there, you need to have really clear shared expectations in your team about what you're doing. Because if you don't, everyone's going to get upset. And this goes back to leveraging disciplined habits inside of your team versus enforcing explicit architecture designs. And this is very much a social methods, culture over inflexible architecture argument. You can go back and forth on this. You can use lots of architecture in APL if you want, but you're not going to gain the same amount of benefits, would be my claim. So explicit architecture is a kind of boilerplate that I want to get rid of, but implicit architecture is the bedrock of good design. You want to have an architecture, but you want your architecture to be a really clean design that you don't see in the code except as it manifests through the shape of the code already. And this is, I think, a difference between a good APL architecture and a bad APL architecture, is you don't need to be explicit in your architecture. If you can design your structure and you can agree on that understanding with your team. So where does that leave any explicit architecture? If we're going to do implicit architecture, what explicit stuff do we have to do? Well, that's all about how do we integrate APL with the rest of the world. And fortunately, Morten Kronberg is going to be releasing a series of short videos that replicates his 7 deployments in 5 × 7 minutes talk that he gave at FunctionalConf. And what this is a series of deployments that show you how to deploy and how to architect your APL session for deployment in various environments. And so we have, these are the sets of environments that you're going to be able to see when these videos are released shortly. On the machine, we got full stack APL, which is Win32, cross-platform, and just the interactive APL session. We have the Chrome embedded framework by default in the Dyalog runtime, so you can get a web-based desktop and web app within APL without any libraries. We also have an embedded APL structure, so you can access APL from a shared library, which we're going to demo with Python, or through a .NET assembly, which you will demo with PowerShell. And you could obviously use .NET assemblies from .NET Core in your other platforms like Linux or Mac if you wanted. So additionally, there's the services section. So you can see how to deploy a Jarvis-based web service using the Docker containers. And same idea using serverless Lambda. And these are all nearly push button at this point. They're very, very easy to do. We have Dyalog APL Docker containers that come out. They're freely available, ready to use. You do need a commercial license if you're going to use them commercially. But if you want to see more about the architecture of this, you can look up Jarvis and saws and things like that. So then the other question here is, how do you actually organize your code inside of an APL system? Because if I'm advocating this minimal architecture, well, what's the structure? Because even literature has a good structure. It's not like you don't have a structure just because you don't have an explicit outline and bullet points. You need some kind of structure. And I've thought about this a little bit, and here's my little sketch of how I think about this. I think of my APL system maybe a little bit like a pie, and each of the various components is a slice of the pie, and it's designed to look through those components, consume them in one direction, say clockwise, and you go through each slice one at a time. And that's how you read it linearly. And each slice is connected to the next slice by a shared edge. And so you sort of expect a shared data transfer or an interface between these, and you expect them to talk to one another in this sort of data flow oriented fashion. But there's this single point in the middle where all of these slices touch each other. And that represents the idea that I also want to allow disciplined ability to access any of my areas at any time. So I don't want to block any of these modules off from any of the others. So they're all able to talk to each other, but we just control that in a way that you are really crisp about what piece accesses what piece, and you maintain this sort of overall structure and ordering as much as you can. And then each slice I like to think of as a one slice to one outside window. So one of these slices will use the available tooling to communicate with the outside if they need to. And I often like to slice at the domain and interface level. So if I need to communicate with the external world, that might be one slice. If my domain changes, if I'm fundamentally working in a different domain, well, now's the time to change my slice again because I'm working in a different domain. So for instance, in my compiler, that would be the parser versus the code generator. Or if the interface fundamentally needs to change. So architecture in general is a hard abstraction. I want to be very careful in how I use it. I use it at the very top level, and I minimize my use of it inside. So I don't want internal architecture. I want to have architecture that's mostly focused on domain level or ground level and not in between. Now, there's a big missing gap here. Front end, I don't have a good solution for front end yet. I'm still working on it. It's an active project. But at the moment, I don't think there are a lot of good solutions to front end right now for most programming languages, and APL is no exception here. It's still a missing link. I don't have a good answer to it yet. you know, I've got some stuff that I consider state-of-the-art and most well-suited to APL development teams if you want to do that. But otherwise, I just don't have a good answer for front end right now, unfortunately. So let's talk about method. Again, method falls on a spectrum. You've got your agile versus your heavyweight methods. And obviously, there's a method gap here because APLers have been doing certain things a certain way. There's a big gap in how do we do modern APL development from a methodology perspective. So rather than suggesting an all-new method, I'm going to suggest some recommendations just in general of how I would look at APL development inside of a team that's already focused agile or focused heavy. So agile, APL will allow you to do more extreme agile approaches than other languages might allow you to, so you can lean into that. You can eliminate some of the practices in agile that are mitigations of language limitations if you can leverage APL to take the place of those practices. I would also recommend maximizing APL as a shared notation to increase the fluency with the language. And I would lean into any more shared knowledge practices that you can. Make sure you're leveraging that. Don't take those out of your agile practice. Intra-system transfer, put that in. Make sure that's a big part of your agile. Don't take that out. I would say sometimes this part also gets dropped in agile, and I would say don't drop it. Mandate your refactoring and learning as explicit objectives. Do not remove this if you're going to start a new APL project, because you need this to get better and to improve your team efficiency. And that's going to be critical. And really, because competency is going to be a limiting factor here, and you have to get up to speed as much as possible, and leveraging the agile processes to improve your competency is a big aspect of this. So refactor and revision are essential to learning, and one of the two big practices in agile that are going to allow you to improve your competency as quickly as possible in the real world. And this means you are going to need to factor in that time, especially on a new APL project. Don't assume you're just going to be able to pursue APL at the same rate and the same time. And I've seen people do this. They just assume they can plug and play this thing, and it's not how that works. So don't underestimate your time to fluency. Now, in traditional teams, a lot of APL teams do have some traditional elements to them that are heavyweight. So one of the things that you can take advantage of is, because APL is so high level, you don't have to have such a high specification resolution to make it effective to use APL for certain problems. So you can play with your specification resolution a little bit there. You do need to schedule in more frequent refactors just because of the nature of learning APL. You're going to want to increase your use of discovery processes. So I would put a discovery process in at every phase so that you're essentially always doing a prototype that you throw away and rewrite at each of these phases initially. And that might seem crazy, but that's what I would recommend. Look into using APL as a specification language in your design teams. And for any project that you're going to target, give yourself space to carve out, make this an APL space that is very clearly separated from the rest of the world to start with, so that you don't have to deal with conflation of style between the two systems at the beginning when you're trying to learn this stuff. And traditional teams have one really big advantage, and that's upfront design. That's a huge potential advantage to a traditional team if you can use it right. So leverage that and make use of APL in the upfront design to really clean things up and create some really crisp designs before you start getting into your development, and leverage APL here if you can. So now, what do I recommend from a method standpoint? If we're just going to start from scratch, a new project, it could be a new project embedded in a team that's going to do something else, or it's just some sub project or something that's a self-contained APL project. What do I recommend to get started? If you want to sit down and you want some kind of framework to structure your team and how you're going to approach this problem. And I don't have the perfect solution, but honestly, I think you just start with extreme programming, the agile methodology. Just start with that. That would be my recommendation for the best fit that I've seen so far right now. And that's just what I would go with. And the reason for this is that it's really well suited to a modern APL approach. And APL can help mitigate some of the drawbacks that people find in extreme programming. And so they fit well together. And I think as far as agile goes, XP philosophically just maps well to APL. And if you can leverage that, especially the small team aspects with the shared code responsibilities and the iterations and the way you approach simplicity, the whole 9 yards in XP, I think that's a good recipe to start with when you're doing a new APL project and figuring out how you're going to organize it inside of a team. And I've seen teams that do this really well. And if you don't do it this way, I think there can be a lot of problems depending on how you approach things. So that's my approach depending on your competency level. But yeah. So in addition to that, I wanted to end my very quick, not so quick, discussion over all this stuff with what I would call my extreme personal habits. So now these are no longer general recommendations. These are things that I do to enhance my own personal APL practice, and some people might find them helpful. And I think of this as a little bit like a biohacking to get clean code. So to start with, I think this is actually really tied to your personality profile. So I would recommend, before you start looking at these things, do a really good Big 5, 10 aspect scale personality profile on yourself and identify certain important traits here, because those traits are going to matter in terms of how you design some of these things to maximize your effectiveness with the code. So for instance, I'm high orderliness, low industriousness, and high trait openness, and that's going to affect all of these design choices. So I'm going to try to maximize those strengths and minimize the weaknesses that I might have from different traits that I have. So psychologically, I want to incentivize clean code. That's how my habits are designed. I want to, really try to get my mind constantly working on that rather than making it a chore. So one of the things that I do is I just use Notepad as my editor. And that forces me to not rely on a bunch of things because I only have the simplest editor possible. So it doesn't let me get away with things. I introduce really strong visual limits into my code. So I restrict my structure. So I have, fairly strict column count limits, and I have certain indentation limits, and I don't allow certain nesting, and I don't allow certain spacing and things like that within my code, so that it forces there to be a very, almost like a poetic timbre or rhythm to the code that enforces itself. And this helps me to see anomalies in the code very easily because of their visual aberration. I don't do much unit testing, if any at all. I've got a blog post on this, but I prefer to avoid the unit tests, because I think the unit tests just introduce too much internal complexity and are an excuse for internal architecture. Instead, I rely almost entirely on black box user level test cases or stories and infrastructure that only tests the external, not the internal units. And I found that to be very nice for me. Obviously, some people would deeply disagree with this, but I prefer it. I also try to do a lot of dogfooding if I can. I have as a philosophy to minimize my control flow. Not that I couldn't introduce control flow, but as a way of sort of forcing a constraint on myself to help me to simplify my code. Additionally, I also try to structure my code in a linear data flow style, so I avoid the nesting. I try to avoid jumps in my code, make it linear, make it flow. I minimize my nesting. So I'm doing everything I can to minimize nesting in my code. And if it gets too complex, find another way of rewriting it so that it's not too nested and is still readable. I also introduce almost no comments because the comments are almost always an excuse for complexity. In my personal life, I found when I introduce a comment, it's because something doesn't make sense without the comment. And it doesn't make sense because the system's too complex. So it's better to just get rid of the complexity rather than write the comment. Another way I do this is I force myself to use a global namespace. So I don't have a lot of things hidden inside of internal namespaces. Instead, all the variable names predominantly exist in the same namespace. And this prevents me from getting too fancy with my names because I have to be cognizant of all the names that I'm using in the entire system. I also do the same thing with my file system structure and my naming conventions. I try to keep them short because if I can't remember them or if I don't know how they're used, then I either have too many of them or I need a better structure or I've got to do this or that. And it helps me to trigger pain when I'm not being simple. Same thing with file names, right? I sometimes, like with the Codefense compiler, I just got rid of my file names entirely. I just named the files A, B, C, D, E, F, and G, right? Because I didn't need that extra complexity, and I wanted to avoid letting myself get away with it. So what I do use as a tool is, rather than putting stuff in comments, I contextualize my notes through version control so that all of my notes happen at commits or things like this, so that I can see the entire piece of code as it was when I was making that comment. It gives me an idea of what I was thinking at the time. So I can always go back and find the justification for why this is in the code, right? So if I see something, I'm like, that doesn't look right, can't be right, I can always quickly pop up the history for that thing and look at the commit message around there and find, oh, this is why that piece of code is there. And I can look at the context for why it was there. And then that allows me to say, oh, well, this made sense back then, but now this is clearly no longer making sense. And I have the justification. But that's the way of using a tool so that it doesn't subjugate me and instead helps me to make simpler code rather than increasing complexity in the code. Again, open transparent structures. I'm often using leaky and ephemeral abstractions. And I try to, as much as I can, to make complexity painful for me, to incentivize me to simplify that code. So, you know, I try to make any anomalies feel odious in some way or another. And I try not to hide bad code. It's very common. I see it really everywhere. If somebody says, oh, this is bad code, they just try to hide it away and say, we'll deal with it later. I try to make that bad code as front and center as I can, so I can never not look at it, so that I'm constantly being reminded, and then I just eventually will get so tired of seeing it that I will fix it. So that's a way for me to force refactoring. So a lot of this is deeply tied to my high orderliness trait. And if I weren't as orderly as I want, I'd be willing to put up with a lot of the things that I'm not willing to put up with in the code because it bothers me so much. So what if you're not orderly? Well, then you better hope your high trait aspect industriousness, because that's the other aspect that allows you to get things done, right? So you can leverage your industriousness to put checklists in place or other things to get things done that you just follow and will allow you to, you know, churn through these things and make sure you never forget something. If you're low industriousness and low orderliness, I'm sorry. I don't get better at one of those. Low openness, this has to do with how much you're willing to deal with abstractions. If you're low in openness and you don't appreciate the open-ended exploration process, then you have to get better at keeping a large suite of idioms with you in your working set, and you have to have a stricter style guide and more rules about how you're going to apply this stuff, and you have to really leverage those idioms in your code, because otherwise you won't see the patterns as easily. So this is all towards emphasizing that emergent behavior, getting clarity and macro thinking about the code versus other things. And that's, now obviously not everybody agrees with me on this. So a lot of people have very different ways of approaching this. This is my take on it of how I think modern APL should look going forward and my recommendations, but I've given the justifications for that. So I hope that people can take that and then see that where it is. I would recommend also, don't embed fear in your code. And this is something I came to realize recently looking at some more of our case studies, is a lot of people don't get something working but aren't confident in it, are not confident in it, or they don't really understand it, and intuitively they know that. So fear gets triggered in their head, they're afraid, and so they design their system around that fear, and they are afraid of getting rid of something, or afraid of changing something, or afraid of this, or afraid of that, because they don't have confidence in their system. They haven't architected their system to give them confidence. They've designed it so that they can be afraid. And I think you should really try to not do that in your code. So try to help your tools motivate your mind to do stuff, not essentially subjugate you into relying on them to get work done. And then finally, this is all primarily about maximizing the simplifying affordances in your system. And whatever you can do to do that is going to be a win, depending on whatever works best for your team. But that's the overarching principle that goes with it. So that's what I've got. I know that was very fast. So I'm going to take a breath here and do a little reading and see if we have any questions or comments, and go
We've
from there.
got both.
Okay, cool. Anything that stands out, or should I just go through chat?
So I'll go ahead and read them, and if you want to intersperse with things that you're reading, go for it.
Sure.
So our first question was, what is an example of an anchor point?
Okay, good question. Good question. So this is, there's two aspects of anchor point. They're kind of connected. There's the psychological anchor points, and there are the architectural anchor points, and they're often connected or correlated with one another. So for instance, you might be used to having your modules divided in a certain way, or an anchor point might be in the export-import barriers that you create in your code that you expect to be there. Another anchor point might be, for instance, psychologically, when you're thinking about a problem, you might be used to scanning your code and looking pattern-wise for the control flow statements. So an anchor point for a lot of people is the pattern matching statement, or the type statement, or the if statement, or the loop, right? So, you know, like when you're reading C code or scheme code, you might look for those let loops, or for your for statement to provide some information about your structure. Or you might, there's also the anchor points of feeling, and this is a more subtle one, but some people have a certain rhythm and feel when they get into their code. So they're used to seeing the code scroll across their screen at a certain rate. And their sense of progress in the code is driven by activity that appears on the screen, right? So an anchor point for them is movement on the screen and typing on the keyboard or something like this. And it sounds funny on some level, but this is something I've noticed is for a lot of people, there's a deep psychological connection between that thing happening and progress. So they don't feel like they're achieving anything if a function isn't being written, or a piece of code isn't being changed, or something isn't happening, right? And so if something isn't happening to them, they don't feel like anything's making forward progress. When what they might really need to do in APL is take a step back and say, what is the domain we're working with, and what are the implications of that domain, so that we can come up with an understanding of what is the actual solution to this problem. And maybe they need to do something to get that anchor point back within the APL community, within the APL. So maybe they need to sketch something out that allows them to explore that domain in a certain way. Maybe they need to get onto the REPL and explore something. But that anchor point might have disappeared for them because they're not being required to write all of this boilerplate code. And so a lot of times those boilerplate code forms an anchor point of their expectations, and their brain is triggered on certain sensations when they write that code. And that's a big one that I think people don't realize that hits them. It's easier to understand, oh, you don't need this in your code because your architecture is simplified. But oh, you're feeling uncomfortable in this code because you've lost some of the things that you are used to seeing that trigger habits in your brain. Well, now that's a thing that they don't often realize is happening to them, and it's connected to dopamine and all of those other things. Does that? Yeah. Okay.
Okay. So I think as a kind of a follow-up question, do you consider APL to have fewer anchor points, different anchor points, or maybe fewer and different?
It actually has many, many, many more anchor points, but they're very, very different. So the design of APL was built around the principle of, what does Iverson call it? He calls it suggestivity. And the idea is that suggestivity should, in the language, is essentially another phrase for saying there's many, many affordances in a given phrase. So the idea is that the primitives and the language and the syntax are designed to have many different affordances, to suggest lots of different opportunities to you. The problem is that people are not used to seeing those opportunities because they're not used to engaging with code like they would an algebraic expression. And they're used to many fewer anchor points that are very restricted in which way you go, very constrained in the direction. Whereas in APL code, the affordances are nonlinear and they sort of go everywhere. And so you have to recognize those. First, you have to be able to recognize those anchor points, and then you have to make sure that whatever you're doing in your method allows you to filter those anchor points to the useful direction that you need to go in, or leverage that as domain transfer. So I've talked about this in past talks in terms of serendipitous transfer. And those are affordances that the language provides to connect an idea that you have already to another seemingly unrelated idea.
Okay. So as a kind of an aside, somebody wanted to ask if this could be in a repo with links or actual commits for the resources and references.
Oh, yes, yes. That's a good point. I shall work up a blog post to link those together.
Wonderful. And if you could send me the link, I can post it with the video as well.
Yes, that's
cool.
A good idea. Yeah.
Okay, so next question. ClojureScript and Shadow CLJS might be useful sources of design inspiration for front end in a functional languages. Or
yeah. So there's a challenge here on the front end languages, because I'm not convinced that the way we're approaching language design and front end design are actually correct as a matchup. I'm not convinced that the way we approach language is the correct metaphor for engaging with front end. And part of this is that the thing that makes the most sense to me is front end as data, not front end as computation. And I think that some of the newer systems are getting at this a little bit more. Like Svelte has begun to get at this a little bit. Some other systems have begun to get at this from a user experience point of view. But the big problem for me still is that we don't have the correct tool of thought for front-end language. Nothing has reached the point where it's a tool of thought. Everything is an implementation of a separate abstraction. And that's not sufficient for me. In order for it to be APL qualified, it has to be a fundamental tool of thought that doesn't require a fundamental jump in abstraction levels between the way you express the front end and the front end itself. The two need to be sort of conceptualized as the same entity at multiple different levels and different dimensions. And I haven't seen a front end system yet that does that correctly, especially on the web right now. So I'm even looking at things like Editor X or some of these other things to see what they provide, because the way we're doing it right now just isn't good enough for what I consider necessary to really take that leap in front end that makes it APL usability level, if that makes sense. So, yeah.
You just expect better out of your front end.
I expect more direct out of my front end. I don't want to have to go through all of these loops to express my front end. Like if I draw it, I should know it. It should be like there's an indirectness in front end design right now that's still way too abstract for people to really model it. Yeah.
Okay.
Sorry, I don't have any idea which idea was amazing.
That's okay. I think somebody wants to know where they can buy an APL keyboard.
Yes, you can. There's Unicomp sells a traditional IBM APL keyboard, and I think Dyalog has some APL keyboards with the Dyalog keyboard layout in it. And I think you can get some custom cherry key switches printed with the APL key maps.
Okay, so as a follow-up to what I think we talked about, either the last question or the question right before that one, was somebody's wondering, a set of operations on the DOM given a state, but what about graphical artifacts expressed as coded elements?
Okay, so I will say a set of operations on the DOM, I consider that now a solved problem. See my thesis. So a set of operations on the DOM is just tree transformations and tree traversal. And that's a well understood problem. We've got really good ways of doing that in APL. But I'm not convinced that that's the right level of abstraction for front-end design. And so the graphical artifacts, the design, the way I look at it is the people who know the most, the domain experts of front-end design, what do they do? How do they think about the problem? And how do they express the problem? And if we look at that and it doesn't look like an executable thing that we can work with, then it's insufficient. And if the thing that we want them to use is not what they would naturally use in their domain, that's not going to work, right? It needs to be a domain expert, fully general approach to this problem. Villagers demand links to keyboards. Unicomp, I think. And yeah, pckeyboard.com. Yeah, that's the stuff. Yeah.
Next question while we're dealing with the villagers. Can you talk more about highly available, larger than memory storage of data with a high number of write or reads with no data corruption? And or integration with Postgres, or should I stop there and then continue the rest of the question?
Let's see. I'm just going to high level, larger than memory, right?
Yeah, highly available, larger than memory storage of data with a high number of write or reads with no data corruption. And or integration with Postgres and what is involved with converting vector data to Postgres read and writes.
Okay.
And additionally, one can use Amazon supported DBs, but what do you do in APL to make sure that your data never becomes corrupted?
Right. Okay. So it depends. So it depends on the types of data you're working with, depends on a lot of things. The one solution is you can just hook up to an RDBMS system and use an existing high performance platform. But most of those aren't actually high performance platforms. Postgres isn't really high performance. Most of that stuff's not high performance. The larger than memory storage of APL artifacts is quite easy because you can either use memory mapped files if you're going to be read only, or you can use component files to very easily store very large files, and you can get full journaling, checksum, and authentication and integrity verification with those component files. The danger with the component files is that they're not going to be as high performance as some other systems. So in some of the real world work that we've done, we use careful design to eliminate contention, and then we allow for essentially blocks of native file updates and leverage the native file reliability. So we leverage whatever the journaling system is of your high availability storage system, and then we design it so that we don't require the same synchronization guarantees that other systems might use, and so we don't have to have a central entry point into that file system. And this helps with the parallelism and the high availability and things like that. So some of it is custom crafting because we know that we're going to get certain things. The big challenge is when you want to combine high amounts of writes in non-linear fashion with very large amounts of non-linear writes to a structure that can't be decentralized. And that you're either going to have to leverage existing systems, or you can leverage your computer science knowledge to implement that with high availability. Or some of our really, really big clients have a combination of caching servers with the component file server to do very high availability, very massive, larger, not just larger than memory, but larger than network. Yeah, larger than network files. So one of our clients, I think he's got a talk a few years ago at the Dyalog. Now they're a very heavyweight operation, so keep that in mind. They use architecture, like a hammer on things. But what they have is they have an architected APL system that uses, basically it slurps in data from all over the world in a database that is always and constantly changing. So they can't ever determine how large the database is because they can't actually compute the size before the data changes underneath them. So in that system, they've got the ability to pull in all of these data sources, and they do lots of caching, and they design their systems to read from the right places and do the caching, things like that. And that's what I would call taking a traditional software engineering approach to it. What I have found for the majority of cases is that very often you don't need, there's one or two factors that you can latch onto as unnecessary. So very often, for instance, you need high read, but you don't need high write. And if you need high read but not high write, you can architect your system a little bit differently and simplify it a lot, right? So one of the systems that we have has high write but very local read. So there's really good data locality. And because there's really good data locality, we can divvy that up in a way that allows us to essentially guarantee that we can spawn as many systems as we want to handle as much as we want, and there won't be any synchronization overheads on the system, except for what we access through the file system, and that's going to be accessed on potentially different disks or anything. So it really depends on figuring out what that key structure is that allows you to simplify your architecture versus the worst possible case. And almost all the problems I've seen, from like ML to all these others, they usually have one or two of those key things that allows you to greatly simplify the architecture, and then you can leverage stuff. So, you know, you can, yeah, I think that's the answer really, is there's no right one solution, but you look for that one thing that allows you to cut out the 80% of your architecture and then get all the advantages. So most of it's just plain APL code coupled with a few extra things to handle that extra little bit you need. Sort of an 80-20 thing.
Great.
Yeah.
Well, I think that, you know, works for me anyway.
Yep.
If anybody has a follow-up or has additional questions, let us know. But other than that, that was our last question. So thank you, Aaron, so much for this presentation on APL in the real world.
Thanks. I apologize for it being so long. I tried to keep it short, but I realized that, you know, it's a lot.
This is one of the beauties of the global edition.
Yeah, you might have to play it back at half speed or something.
We're not, you know, like switching rooms, and we don't have a time limit that's like hard and fast for your attack. So, yes. You know what?
If you do care about the keyboards, actually, I have a blog post on my latest fascination with low-profile linear key switches for my programming. So you can feel in the real world, that's the keyboard I use.
There we go. We'll post that for you on Discord or something. So
yeah, sure. Thanks a lot.
All right. Oh,
what do we have here?
Is production. How do you deploy a compiled app?
Okay, great.
In production.
Yes. So APL in Dyalog APL is not compiled, not in the traditional sense. So what you do instead is you deploy a workspace. Very often, the way most people do it right now is they deploy a workspace. And that workspace is a binary system containing all of your code and data, but it's not compiled. It will be, on Windows, for instance, the workspace is attached to the runtime, which is wrapped in an executable, an exe. And then that exe is distributed. And that executable file, when it loads, launches the runtime and runs the entry point into your workspace. And there's a flag or a feature in Dyalog APL when you deploy to disable the ability to go into the debugging system. So it's a runtime only system, and disable the introspection features and actually to obfuscate the code that's inside of it to some level. So that prevents people from being able to directly extract out the code or directly introspect into the code and change the running behavior, or to pull out that stuff. It depends on your application. So if you're doing fork join parallelism, then it's fairly straightforward. If you just want to do SIMD parallelism, it's automatic. If you want to do GPU computation, you do have to go through the Codefonds compiler, which I would which is sort of a bespoke thing at the moment. So that's definitely more clunky than it should be. So GPU computation is probably the highest performing but most fragile at the moment. The isolate system will let you do fork join distributed parallelism. And that's actually fairly easy because there's built-in support for futures. So it's fairly easy to do that. No worries on that front. But if you're looking for syntactic ways of expressing parallelism, that is a different beast. There's no sort of special syntax for APL except the parallel operator, which spawns a parallel thread inside of the isolate system. So I would look at some of the talks that Morten has given on the isolate system, especially the most recent ones. It is getting to be a pretty clean system. But if there's a particular application you're trying to do that doesn't work there, let's talk about it, and we can figure out where it is. It's a lot of the times I find it's a design problem, not so much a limitation in the runtime, as people have a certain architecture in mind, and you just don't. That's just not as clean an architecture as what we expect to be used in Dyalog. So you change the architecture and it solves the problem. Another aspect is very often I've encountered the case where you don't need to use as much parallelism or concurrency in the system because the system's fast enough not to require it, and it's easy to just spawn another workspace. It just depends on the situation. So, yeah. But definitely there are things planned in the future to improve the state of broad-scale distributed high-performance computing on like GPUs and clusters and things like that we can definitely improve on.
I think that's kind of a general thing. Everybody can improve at least something at some point, but.
Oh yeah. There's tons of things to improve on.
Yeah.
Always.
Okay. Well, Thank you very much, Aaron. Really enjoyed today, and we're happy to have you as always.
Thanks a bunch, and feel free to send me an email with any other questions you have, or send them through Discord, or if you'd just like to chat and give your feelings, I'm open for that too.
Yeah, you can find Aaron on Discord.
Yeah.
All right, thank you very much, and we'll see you all hopefully next Tuesday.